Hello everyone, my name is Mario Tiozzo and I am the Data Analysis and Visualization Librarian here at UNB Libraries. Today we are going to take a look at how to analyze the CMS's data on HAI, or Healthcare Associated Infections, in the US. Once the data has been analyzed, we will try to use it to answer a few related questions. First, let's download our dataset. The data is located on the CMS data page, data.cms.gov, but it's a little tricky to navigate. So let's just type in CMS Healthcare Associated Infections by state in our search engine. The first entry is the one we want. And when we click on it, we note that it is a dataset. That's perfect. We can see information on the dataset at the top, including some context, when it is updated and it was released. There's also additional information below the dataset. And we note that there is a data dictionary on the right-hand side of the dataset. Let's quickly open that up. You can see that it is very thorough, where it explains the context, the variables, and goes into a lot of details of all the elements we may come across. This is a great resource to peruse if you have any questions about the data. Okay, let's get back to the data webpage. This is the data that we want, so let's click on Download Full Dataset. Click on this, open it up on Excel. If you don't have the opportunity to click on a tile, the file will usually land in your downloads folder. Okay, here's our data. We note that it's broken down by states, measure ID, measure name, score, footnote, as well as start and end date. It's a bit hard to see, so let's adjust the columns. Let's highlight all the columns. Let's go to the edge of one of the columns, double click, great. When dealing with a dataset, I oftentimes like to convert my data into a table. To do so, just press Ctrl A to get all the data, and then Ctrl T to convert into a table. We do have headers, so we'll keep that option clicked and we'll press OK. Our data is now turned into a table. We have the option to name the table here. I'll change it to HAI. Great. It's a fairly big dataset. If we press Ctrl Shift down, we note that it has 109 rows. Let's quickly explore our data a little bit. Footnotes seems like it would be revealing. Let's inspect it a little bit. Let's filter it out. We note that we have either blanks or the number 5. Let's just select the number 5 and see what comes up. We note that every time there's a number 5, the score becomes not available. What's that all about? Let's check the data dictionary to see if we can find out more about it. Let's press Ctrl F for the find function and let's type in footnote. Okay, OAS footnote crosswalk. That doesn't seem to be quite right. Let's go back to the top and start over. Appendix E footnote crosswalk. This is promising. Press on that. Great, look at that. We have the numbers on the left and what it means. So if we go to number 5, we see that the results are not available for this reporting period, which we already knew. What does the definition say? This footnote is applied when a hospital elected not to submit data for the entire reporting period, or when a hospital had no claims data for a particular measure, or when a hospital elected to suppress a measure from being publicly reported. Great, that gives us some good additional context. Let's go back to our data. Now we know that every time footnote 5 shows up, the score not available shows up. Let's make sure that there's not other not availables in this data set. Let's clear this. Let's filter out just the not availables. See what comes up. Okay. It looks like not available only shows up when there's a footnote 5. That's good to know. To clear the filter, get back to our regular data. All right. Now we are ready to start analyzing our data. In this instance, we are only interested in the data for Louisiana, New Mexico, Oklahoma, and Texas. Because this is a somewhat large data set, one of the ways of analyzing the data would be to create a pivot table. So let's do that. Click anywhere on a table, click on the Insert tab, click on Pivot Table. You'll notice that table/range has identified table HAI, which is perfect. We can either put the pivot table on a new worksheet or on an existing worksheet. In this instance, let's use new worksheet. Press OK. Now what? This is the seed of a pivot table. On the left, you have what will ultimately become your pivot table. On the right, you have the potential ingredients for your pivot table. Notice that they are all the fields in your original data. Below that, we have filter, column, rows, and values. Let's put the state field in the column section. To do so, just take the state field and drag it into the column section. Notice that your pivot table has now transformed, and on row 3, you have all the states in your data set. Now let's put the measure name in the row section. Take the measure name and just drag it to the rows section. You can see that this creates a grid or an index of sorts. Finally, let's put the score in the values section. Take the score and drag it to the values section. You can see that in the values section it says count of scores. All the numbers are ones, so it counts it once every single category. This is not exactly what we want. So let's click on this drop-down menu, value field settings, and instead of count, let's put sum. Now we see all the values in our data set. Let's right adjust here. Perfect. Note that the title on the pivot table now says sum of scores to indicate what is being represented in this pivot table. Also note that clicking out of the pivot table takes away the pivot table fields. Clicking back on brings it back. If you ever lose your fields table, for example, if you press X here, but you want to get it back, you can simply press field list and it'll come back. Speaking of buttons, some of you may have these headers show up on your pivot table. I don't particularly like them, so I have them automatically come off, but if you want them, you can either press them to come on or off by pressing the fields header button. This is still a lot of information, so let's try to filter out some of the data to help us answer our question. Remember, we only want to know about HAIs in 4 states: Louisiana, New Mexico, Oklahoma, and Texas. So let's filter the pivot table to make it more meaningful to us. First, we want to eliminate the items with the words confidence limit in the first row and just keep the data for the infections. In order to do so, just click anywhere on the first row, right-click, go to Filter, and Label Filters. Now you have a drop-down menu that you can go scroll down to, and we want to use the command does not contain confidence limit. Now all the elements that contain confidence limit have been removed, or filtered out rather. Let's do the same thing for the states. Click here on states. We have a drop-down menu, and we can just select the 4 states that we're interested in. So we're interested in Louisiana, which is LA. We're interested in New Mexico, which is NM. We're interested in Oklahoma, which is OK, and Texas, which is TX. Great. Now we only see those 4 states plus the grand total. Let's right-size our column again. We now have our working data set. Now let's try to visualize this. For doing so, let's click anywhere on the pivot table, click the Insert tab, and we're going to be using a column chart. So let's click on the column chart here. We have a whole bunch of options, but we'll pick the first one. Press OK. We'll enlarge it to better see all the text. Just squeeze it down here under our pivot table. Terrific. Let's click the Fields button to remove the gray text in the chart. Let's also remove the grid lines and the border. We can do so by clicking on the grid lines and pressing the Delete button. Right-click on the chart. The Format Chart Area section come up on the right-hand side. Check borders and no lines. Terrific. We also note that our data doesn't go above 1.4, so let's try to work on our axes a little bit. Right-click on our axes, press Format Axes, and again, on the right-hand side, let's change maximum from 1.6 to 1.4. Finally, let's adjust our legend. If we're going to use a legend, it's better to be at the bottom. So let's click on it and check bottom. This is better for the reader because it progresses through the data in the same way that it is depicted on the chart, from left to right. Depending on who our audience is, we may also want to rename our states because LA and NM and OK and TX may mean something to some of our audience members, but it may be confusing for other audience members. This chart is okay, but it could be better. Depending on what we were trying to show with this data visualization, we could play around with the color selection as well as a sort order. We would also want to include a title and possibly a subtitle that explains our main points to the audience. But for now, let's just leave it as is. Now that we have all our data the way we want it, Let's try to answer these 3 questions using our data. First question is, which state has the highest SIR for surgical site infections from colon surgery? So in order to answer that, we probably want to use the last row here, SSI colon surgery, and see which state has the highest SIR. Now, because we only have 4 data points, it's pretty easy to kind of eyeball it and see which number is the lowest. But if we had a data set that was significantly bigger, it might be more confusing or arduous to do so. So let's use conditional formatting to help us out, even though this is a small data set. Let's highlight our 4 data points. Let's go to conditional formatting. We want the highest, so let's go to the top 10 items. And let's go top 1, so the highest item. So in this instance, Oklahoma has the highest SIR, or standardized infection ratio, for surgical site infections from colon surgery. The second question is, which state has the lowest SIR from MRSA bacteremia infections? So let's use conditional formatting again with a little bit of a twist. In this case, we want the lowest, so let's go to the bottom 10 items, and let's go bottom 1. But here, we won't highlight it in red, just to make it a little bit more of a contrast. We'll highlight it in green. So in this instance, New Mexico has the lowest rate amongst the 4 states. The final question is, which state seems to be doing the best overall with respect to preventing HAI, and the worst? Hint, this requires you to now group by state. So in this instance, we're going to be going to the grand total over here and doing effectively the same thing. So we'll do conditional formatting, top 10, and we'll go 1, and conditional formatting, top bottom, bottom 10, 1, and green. So overall, New Mexico has the worst HAI of these 4 states, and Texas has the best HAIs in these 4 states. That's it for the questions. I just quickly want to circle back to why I had you create a table at the beginning of the video. Let's go back to our original data. Let's go all the way to the bottom. So not only is it easier to create a pivot table via a table, but a table also has other great attributes. One of them is that it automatically adds new data to it, so it's always up to date. So if you were to add 2023 data, for example, to the end of this data set, it would be absorbed by this table, which means that it would automatically be calculated by the pivot table once you refresh it. For example, let's create a dummy row here for Texas. You'll notice that this dummy row has automatically been assimilated within the table. So it's now part of this data set. You don't have to reconfigure the area that the pivot table needs to capture. Let's make it SSI colon surgery here, and let's give it a dummy value of 2. Let's go back to our pivot table and let's refresh it. Let's go pivot table analyze and press refresh. Notice that now Texas has the highest SSI colon surgery, and the conditional formatting has also switched over. So that's one of the beauties of working with a table, is that it's more seamless when you're incorporating new data to your existing data. Let's quickly go back and take this out because it's obviously erroneous data, but I just wanted to use it as an example. And now that we've eliminated the erroneous row, let's go back to our pivot table. And let's go to pivot table analyzed tab and refresh our pivot table. And now all our elements are back as they were, including the conditional formatting. Great. Okay, I think that will do it for today. We were able to download the data set, analyze and visualize it, and answer related questions using our analysis. I hope that this was helpful. Thanks for watching, and I'll see you in the next video. Bye for now.